We're still in chapter 24, and this is the third part of the chapter, which is on energy balance. So bond energy released from food must equal total energy output. And energy intake is going to be energy liberated during food oxidation. And then output is going to include energy that's lost as heat, used to do work, which is going to be driven by ATP, and stored as fat or glycogen. Nearly all energy from food is eventually converted to heat, which cannot be used to do work. But heat energy has some functions. It warms tissues and blood. It helps maintain homeostatic body temperature. It allows metabolic reactions to occur efficiently. Metabolic rate is total heat produced by chemical reactions and mechanical work of the body, and it can be measured two different ways, directly and indirectly. Directly, you would use a calorimeter, which is going to measure the heat that's liberated into a water chamber. Indirectly, would use a respirometer, which measures oxygen consumption, which is directly proportional to heat production. Basal metabolic rate reflects the energy the body needs to perform its most essential activities. It's measured in a fasting state, a post-absorptive state, 12-hour fast, in a reclining position, relaxed, both mentally and physically, and in a room that's somewhere between 20 to 25 degrees centigrade, which is about 68 to 77 degrees Fahrenheit. It's recorded as kilocalories per square meter of body surface per hour. So for an example, a 70 kilogram adult has a BMR of about 66 kilocalories per hour. Basal metabolic rate is influenced by age and gender. It actually decreases with age, and males have a disproportionately higher basal metabolic rate. Basal metabolic rate increases with temperature. It also increases with stress. And then thyroxine is the hormone that's going to influence metabolic rate the most, and it's going to increase oxygen consumption, cellular respiration, and basal metabolic rate. Total metabolic rate is the rate of kilocalorie consumption to fuel all ongoing activities. So under normal circumstances, we are not sitting at a 12-hour fast, reclining, relaxed mentally and physically. Like right now, you may have eaten an hour ago and you may be stressed about the next exam or something else. So we need to measure total metabolic rate, or be able to at least understand what total metabolic rate is. It increases with skeletal muscle activity and food ingestion, and this is called food-induced thermogenesis. And food-induced thermogenesis is going to be greatest with protein and alcohol ingestion. This is the question. This was a really short video, but this is the final question for chapter 24. You guys have a good day.